Hello everyone, this is Dr. Anand, and today I would be explaining about the supervised learning and unsupervised learning. Before proceeding with supervised learning, let us understand the background of machine learning. The term machine learning was coined by Arthur Samuel in the year 1959. Arthur Samuel is an American pioneer in the field of computer gaming and artificial intelligence. And according to Arthur Samuel, machine learning gives the computers the ability to learn without being explicitly programmed. Adding to this, in the year 1997, Tom Mitchell gave the well-posed mathematical and relational definition for machine learning. Mitchell says that a computer program is said to learn from experience E with respect to some task T and some performance measures P. If its performance on T as measured by P improves with experience E. So there is a correlation between three important elements here. One is experience, the other one is task, and the other one is program and performance. So machine learning is the latest buzzword floating around the world. It deserves to, as it is one of the most interesting subfield in the computer science. Let us try to understand the concept of machine learning in layman's terms. Consider you are trying to toss a paper into a dustbin. After the first attempt, you realize that you have put too much force into it. After the second attempt, you realize that you are closer to the target, but you need to increase your throw angle. So what is happening here is basically after every throw, you learn something and you try to improve the end result. We are programmed to learn from our experience. The same concept is even applicable for the machine learning. Now, let us introspect on two important questions. Can machines think? But instead of talking about this question, can machines think? Let us replace it with a new question. Can machines do what we think? What can they do and how can they do? So within the field of data analytics, machine learning is used to devise complex models and algorithms that lend themselves to predict. In commercial use, this is also known as the predictive analytics. So these analytical models will allow the researchers, the data scientists, engineers, and also different client companies to produce a reliable result. And these reliable results can be used for discovering hidden patterns and hidden insights with which they can continue with the decision-making process. Suppose that you decide to check out an offer for a vacation on a website. You browse through the travel agency website and search for a hotel. When you look at a specific hotel, just below the hotel description, there are a series of other items which are popping up. So this is a common use and a very common experience for all of us. This is because of the machine learning technique, which is called the recommendation engine. Again, many data points are used to train a model in order to predict what will be in the best hotels to be shown under the section. Based on a lot of information they already know about. So it collects the past information and it predicts new information for us to take different decisions. Let us understand with another example. Training of students during the examination. While preparing the students for exams, students usually do not actually by heart the subject, but rather they try to learn it with complete understanding. Before the examination, they feed their human brain with good quality of information. It can be questions and answers from different textbooks. It can be the lecture notes from the teacher's lecture classes. It can also be different video tutorials from the online platforms like YouTube, Byju's Education, etc. So actually, they are training the brain with input as well as the output data. So what kind of approach or logic do they have to solve a different kind of questions? Each time they solve a practice test papers and find the performance accuracy score by comparing the answers with a given answer. So gradually the performance keeps on increasing from time to time. They gain more confidence with the adopted approach. So that is how models are built. Train machines with data that is both the input and output, and it would be in a position to predict an expected solution which can be further used for the decision-making process. So that is why the pioneer in machine learning, Arthur Samuel, has quoted this definition. The field of study that gives computers the ability to learn without being explicitly programmed. These days, the term artificial intelligence, machine learning, deep learning are popularly used by many companies. You might think that these are new concepts that have stemmed newly, overnight. But unfortunately, these concepts and methods and approaches have been used by companies for a very long time. Now, let us understand with a very different other meaning. We as human beings take multiple decisions throughout the day. For example, when to wake up, what to wear, what to eat, where to go, whom to call. So these are all the different routine tasks which we perform. So while several of these tasks are repetitive in nature, we do not usually take a notice of. And most of these tasks is done subconsciously. However, there are many other activities that require a conscious thought. For example, if we take business units have to take conscious decisions. They apply their past learning to the decision making related to administration, supervision, operations, and they also take new initiatives like product classification, introducing a new product in the market, market segmentation, fraud detection, etc. However, it gets a little more complex here as there are multiple stakeholders who are involved. So initially, you have to know what is your target and how you want to achieve that. Based on that, you have to collect the data, you have to program your computer, and then you have to predict the expected solution. With the growth in digital technology, humans have developed multiple assets, and one of the most important and valuable assets is machines. We have learned and we will also continue to learn to use machines for analyzing data using statistics to generate useful insights that will aid the business units in forecasting and also to take better decisions. So this is a very basic introduction for machine learning. Now, let us get into supervised learning and unsupervised learning. Under the concept of machine learning, we have supervised learning and unsupervised learning. Now let us understand the concept of supervised learning. Let us take a very simple example. Let's say that we have a fruit basket that is filled with multiple species of fruits. Our job is now to categorize fruits based on their categories. In case we have considered 4 fruits: apple, banana, grapes, and orange. Now let us say that you have picked up a fruit from the fruit basket. You look into the features of the fruit. What are the features of the fruit? It can be shape, it can be size, it can be color. For instance, I grab a fruit from the fruit basket. When I look into the fruit is red in color, it is round in shape, it also has a depression at the top. So I come to a conclusion that this fruit is an apple. I take the second fruit. I observe the features of the fruit. It is round to oval. It has many cylindrical shape of small clusters. It is purple in color, and I call this as a grape. So likewise, you do the same for all the remaining fruits as well. The rightmost column which you see, that is a fruit name, is known as the response variable. This is how we formulate a supervised learning model. Now it will be very easy for anybody, let us say, even for a robot or even for an alien, to find what type of fruits are there in the basket. So supervised learning is an approach where a computer algorithm is trained on input data that has been labeled for a particular output. The model is trained until it can detect the underlying pattern and relationship between the input data and the output labels, enabling it to yield accurate labeling result. Supervised learning is a very good classification, and this will also help in predicting good amount of information which can be used by the companies to take multiple decisions. In supervised learning, the aim is to make sense of data within the concept of a specific question. So how does the supervised learning work? Like all machine learning algorithms, supervised learning is based on training. During the training phase, the system is fed with labeled data set, which instructs the system what the output is related to. The trained model is then presented with the test data. So what is a test data? A test data is a data that has been labeled, but the labels have not been revealed to the algorithm. Why it is not revealed to the algorithm? Because the aim of the testing data is to measure how accurately the algorithm will perform on unlabeled data. So this is how the supervised learning will work. Now again, let us recall the meaning of supervised learning. Supervised learning uses artificial intelligence, where a computer algorithm is trained on input data that has been labeled for a particular output. The model is trained until it can detect the underlying pattern and relationship between the input data and the output labels, enabling it to yield accurate labeling result when presented with never before seen data. It can be very meaningful. It can give you new introspections, new ideas, and it can aid the company in decision making. Like all the machine learning algorithm, supervised learning is based on training. So during this phase, the system is fed with labeled data set, which can instruct the system what output is related to a specific input value. So what are the types of supervised learning? It is basically classified into regression and classification problems. Regression and classification algorithms are supervised learning algorithms. Both the algorithms are used for prediction in machine learning, and they work with labeled data set. That is the most important one. But the difference between both is how they are used for different machine learning problems. The main difference between a regression and classification algorithm is that regression algorithms are used to predict the continuous values. Example for continuous values are price, salary, wages, height, age, etc. And when you take the classification algorithm, it is used to predict, classify the discrete values. Example can be male and female, true or false, spam or not spam. It can also be churn and not churn. So this is also one of the examples for Identifying the difference between regression and classification. What is the temperature going to be tomorrow? So it's quite obvious that it predicts a continuous variable. When we take the classification algorithm, how will it be tomorrow? Whether it is going to be cold or hot. So cold or hot is an example for a discrete value. So this is a very basic difference between a regression and a classification. So let us give a small recap to the difference between a regression and classification. Regression algorithms are used to predict the continuous values, while classification algorithms are used to predict and classify the discrete values. Now let us understand regression. A regression problem is when the output variable is a real or continuous value. I've given you examples before. It can be wages, salary, weight, height, etc. Regression is the process of finding correlations between the dependent variable and independent variable. It helps in predicting continuous variables such as prediction of market trend, prediction of house prices, etc. Regression analysis is a statistical method to model the relationship between the independent variable, that is a target variable, and the dependent variable. More specifically, regression analysis helps us to understand how the value of the independent variable is changing corresponding to an independent variable when other independent variables are fixed. Let us understand with a very simple example. Suppose there is a marketing company A, and this company does different types of advertisement every year and also gets us sales. The picture which you see shows the advertisement made by company in the last 5 years and also the corresponding sales. You can see $90, $120, $150, $1,000, $130, and $200. Now the company wants to do an advertisement for $200 in the year 2022 and wants to know the prediction about the sales for this year. So to solve this problem, there is a need to depend on the machine learning, where we need regression analysis. So regression analysis is a supervised learning technique. Now let us understand few terminologies related to regression analysis. The very first one is dependent variable. The main factor in regression analysis, we want to predict and understand, and that is called an dependent variable. It is also known as the target variable. So what is independent variable? The factors which affects the dependent variable or which are used to predict the values of the dependent variable are called the independent variable. It is also known as the predictor. What are outliers? Outlier is an observation which contains either very low value or very high value in comparison to the other observed variables. An outlier may hamper the result, so it should always be avoided. The next important variable here is multi-collinearity. If the independent variables are highly correlated with each other, then the condition is called multi-collinearity. It should not be present in the data set because it creates problem while ranking the most affecting variable. Now, what is underfitting and overfitting? If our algorithm works well with the training data set, but not well with the test data set, this problem is called overfitting. And if our algorithm does not perform well, even with training data set, then such problem is called underfitting. So these are the most important terms and terminologies related to regression analysis. Now let us get into the different other types of regression algorithms. We have simple linear regression, multiple linear regression, polynomial regression, support vector regression, decision trees, and random forest regression. The next important one is classification. So let us understand classification. Classification is a task that requires the use of machine learning algorithms that learn how to assign a class label to examples from a problem domain. A classification problem is when the output variable is a category. I'll give you an example for that. Red or blue, disease, no disease, churn, no churn, etc. So a classification model attempts to draw some conclusions from observed values. Given one or more inputs, a classification model will also try to predict the value of one or more outcomes. Let me give you an example for that. For example, when filtering the email, we have spam and not spam. When looking at the transactional data, we have fraudulent data or we also have authorized data. In short, classification either predicts categorical class labels or classifies the data. It constructs a model based on the training set and the values, that is the class labels, based on the attributes. So there are a number of classification models which we usually use. So classification models can include logistics regression, decision tree, random forest, gradient, boosted tree, multi-layer, decision tree, one versus rest, and other. However, class labels are often string values. Example, spam and not spam. And it must be mapped to the numeric values before being provided to an algorithm. So this is often referred as a label encoding. Let me give you an example for label encoding. Spam means it is 0 and no spam means it is 1. So that is why I told you before that class labels are often string values, that is spam and not spam. And it might be mapped, it should be mapped to numerical values before providing the same to an algorithm for model. And this entire process is called label encoding. So now let us give few more examples to understand classification. Predicting the gender of a person by understanding his or her handwriting style. Predicting the house prices based on a geographical area. Predicting whether monsoon will be normal next year, that is 2023. Or predicting the number of copies of a music album which will be sold next month. Perhaps there are different other types of classification tasks which you may encounter. For example, we have the binary classification, multi-class classification, multi-label classification, and also the imbalanced classification. What do we understand by the binary classification? Binary classification refers to those classification tasks that have two class labels. Example, in email spam detection, it can be spam and not spam. In churn prediction, it can be churn and not churn. In conversion prediction, it can be buy, not to buy. So these are all the different binary classifications that have two class labels. So typically, a binary classification task involves one class that is the normal state and the another class will be an abnormal state. Let us understand the difference between normal state and abnormal state with an example. For example, not spam is the normal state and spam is the abnormal state. Another example is cancer not detected is an example for a normal state. Cancer cells detected is an example for an abnormal state. So the class for the normal state is assigned the class label 0. And the class with the abnormal state is assigned with the class label 1. So now with this example, I think you'll be able to understand the meaning of classification. Now, what do you mean by multi-class classification? So multi-class classification refers to those classification tasks that have more than 2 labels. Let us understand with an example. Phase classification, plant species classification. For example, iris dataset. When we take the iris dataset, the species of flowers are classified into 3. Iris setosa, Iris virginica, and Iris versicolor. Optical character recognition, that also can be an example. So unlike the binary classification, multi-class classification does not have the notion of normal and abnormal outcomes, but instead, examples are classified as belonging to one among a range of known classes. So now, let us understand multi-label classification. Multi-label classification refers to those classification tasks that have 2 or more labels, where 1 or more class labels may be predicted for each example. Consider the example of photo classification, where a given photo may have multiple objects. In the sense, the model may predict the presence of multiple objects in the photo. It can be a bicycle, it can be an apple, it can be a traffic signal, it can be a car, it can be a bus, it can be a person, it can be anything. So classification algorithms used for the binary or multi-class classifications cannot be used directly for multi-label classification. So specialized versions of standard classification algorithms can be used. For example, decision trees, random forest, gradient boosting. These are all the examples for multi-label classification. Now, let us understand the meaning for imbalanced classification. Imbalanced classification refers to a classification task where the number of examples in each class is unequally distributed. Typically, imbalanced classification tasks are binary classification tasks where majority of the example in the training data set belong to a normal class and minority of the examples belong to abnormal class. I'll repeat it again. In imbalanced classification, it is again a binary classification task where majority of the examples in the training data belong to normal class and minority of the examples belong to abnormal class. Examples can be fraud detection, outlier detection, medical diagnostic test. So these problems are modeled as binary classification tasks, although it may require some specialized techniques. So specialized techniques can be used to change the composition of samples in the training data set by undersampling majority classes and oversampling minority classes. So now let me give you a small recap on what do you mean by classification. Classification predictive modeling involves assigning a class label to the input data. Binary classification refers to predicting One or two classes, and multi-class classification involves predicting one or more than two classes. The multi-label classification involves predicting one or more classes for each sample, and imbalance classification refers to the classification task where the distribution of examples across the class is not equal. Other popular algorithms that can be used for binary classification: a logistic regression, the K nearest neighbors, decision trees, SVM, that is support vector machine, and Navy Base. Now let us understand the difference between a regression algorithm and a classification algorithm. Basically, in regression, the output variable must be continuous nature or real value. But in a classification algorithm, the output variable must be a discrete one. When we take the regression algorithm, the task of the regression algorithm is to map the input value x with a continuous output y. When we take the classification algorithm, it is to map the input value x with a discrete output y. So regression algorithms are used with continuous data and classification algorithms are used with discrete data. Regression algorithms can be used to solve regression problems such as weather prediction, house pricing, prediction, etc. But when we take the classification algorithm, they can be used to solve classification problems such as identification of spam mail, speech recognition, identification of cancer cell, etc. So this is the very basic difference between a classification algorithm and a regression algorithm. So this classification is very important in a supervised machine learning. So now let us take a small recap. So we have learned the following topics: the meaning of supervised learning, how the supervised learning will work, the types of supervised learning, regression meaning, example for regression, types of regression, and important terminologies, the meaning for classification, example for classification, types of classification, and the important terminologies related to classification. We have also understood the difference between a regression and a classification, which fall under the supervised learning. In my next video, I'll be continuing with unsupervised learning.